Hey, Ben, can you hear me?
Yeah, I can. Can you hear me?
All right. So Ben, Interrupt will be here for like all other. You guys are co-hosts, so and the recording will be automatically uploaded to cloud, so you guys don't have to do anything.
Okay.
And um, all right. So I'm going to head out to the IBM session. I'm going to facilitate there. Interrupt will stay with you. He is participant as well as the co-organizer as well.
Okay.
Yeah. All right. Best of luck, guys.
Yeah. How's my audio? Is it okay?
Hello, Ben.
Hey.
Yeah, Antrip here. I can hear you. It sounds good.
Okay, cool. Sure, the screen looks good. You see me okay?
Yep.
Cool. All right, we're at 2 o'clock, so I will get started. Can everybody hear me okay?
Yep.
All right, cool. So this is a brief tutorial on building Docker and Singularity / Apptainer containers. I'm Ben Sandbrook. I'm a HPC systems engineer with Advanced Research Computing, ARC, at Virginia Tech. So start out with what's a container? Containers are basically an application sandbox that you bundle apps with all the dependencies and ship everything needed to run in a very standardized way. You can think of a container kind of like a virtual machine that's not really virtualizing any hardware. It's basically just virtualizing a file system and running stuff on top of that. They're really useful for preventing the runs on my machine syndrome, since all the dependencies can be bundled. So there's a little guy, it runs on my machine, and then his machine is a horrible monster. But you can ship that horrible monster and it will work. So Docker, what is Docker? It's a very opinionated container engine with very widely adopted integrations with tons of stuff. Docker can build, publish, and run containers on a variety of platforms. Now you can walk through this with me if you want, but it gets a little dicey at times here. But I'll just go through what it takes to get Docker up and running pretty quickly. So Docker provides a convenience installation script. You can download it from getdocker.com and then you can execute it. And generally, it will install Docker on whatever platform you're on. You'll need root access to do that, though. So on my machine, it didn't really support it, so I just installed it from the Rocky repositories. So it'll go ahead and install. Right now, this is running on a MacBook M1, so it's grabbing the ARM64 binaries for this installation of Docker. So running your first container, run Docker run hello world. I can actually execute that in this presentation. And it gives me this result, hello from Docker. And it lets you know that Docker is up and running and things are working for the most part. So the run command instructs Docker to run a new container, and then the hello world is the container name, which prints that to your terminal. If you get permission denied issues, which you will right after you've initially installed Docker, you need to add yourself to the Docker user group, or you have to run Docker with sudo. So let's run a slightly more complicated container. So this one is running the Nginx container from Docker Hub. It will name it as, let's name it, names it as Nginx sample, and then redirects the port 80 inside the container to 8080 outside the container. So I believe that's already running, which is why I get the little error. So yeah, it's already running. So after I run this, I should be able to jump over here and see, welcome to Nginx. So that's Nginx running inside of the container on a virtual machine that my Docker is talking to. So let's take that a little bit further, because this is kind of, I mean, it's great to run Nginx, but it's kind of pointless to run Nginx if you don't get to put anything in it. So let's make a little sample site. So there's a little bit of HTML, not much. Hello world, check out my fancy container, and a little bit of CSS to make it a little more palatable. So let's run that over there. And then here's a Docker file. So let me put the paths up here so it makes a little more sense. So this would be in folder source index HTML. And then this Docker file would be in the Docker file path. So in this Docker file, I'm instructing Docker to use the Nginx container image from Docker Hub, and I'm specifying a version of 1.23. I'm copying the files from the folder src, into user share nginx HTML, which is the default location for nginx, the nginx container to serve files. So let's send these over to the virtual machine. And now I'm going to build this this container into a local container, and I'll do that over in the shell. Okay, use the mess. So let's see where we are. Go to Nginx extended app. See what we got there. Let's see. Let's cat out that Docker file. So we have that from Nginx 1.23, copy src, user share Nginx HTML. So pretty simple. And then that intent, it should be index HTML. So that's our index HTML. Don't need that index HTML. Okay. So I have the Docker file, I have the source files there. So I'm going to Docker build dot and then tag it as Nginx example app. So this sends that Docker file over to the Docker daemon. It pulls down the Nginx container and it copies over my stuff over to that. So let's see what's running right now. So I've got that Nginx extended app running. Back over to the presentation. And we'll just run it from here. So from here, I can see that Nginx extended app is running, and it's pointing to port 8081 to port 80 inside the container, and it should come up with my little custom index HTML. So hello world, check out my fancy custom container. Fancy is probably overselling it. So you can do a lot of stuff with Docker. For you guys, probably running Jupyter notebooks is of interest. This is a really simple one-liner to get a Jupyter notebook up and running. And I can actually just go run this now. I'm going to run it interactively since it gives me some output that I need. So it'll go and download the Jupyter Data Science Notebook, which is a fairly opinionated container with a bunch of batteries included. I think R and Python are included in that container. But I should be able to go to one of these. And I can't because I mistyped the IP. Maybe, or maybe I just can't get there. So I'm running this inside of a virtual machine. So that port is probably not forwarded over correctly. Actually, let's see. There we go. Okay, cool. So yeah, in this Jupyter notebook, I have Python, Julia, and R. I can jump into the console. I can see my home folder. I can see what this is running on. It's based on Ubuntu 2204. That's probably very, very small. But yeah, full Jupyter notebook, straight out of Docker, ready to go. Pretty neat. The other stuff, like if you just need a quick interactive shell on something, say you're just on a machine, you don't have root on it, and you wanted to test an installation of something, you can just get a quick little interactive shell. And then, yeah, who am I? I'm root. I can type. Still can't type apparently. So yeah, so I'm in a little Ubuntu container, and I can just jump out of that and it's automatically gone. So it's good for temporary little one-off things. Okay. Cool. So that's Docker. It's kind of a limited usefulness in HPC, unfortunately. Like you saw here is some issues with ARM support. So if I build stuff on this MacBook and push it to Docker Hub and then try to pull it down on something else, generally it'll have my ARM binaries locked into the Docker file. So when you go to try to run that on something in HPC, if it's not set up that way, it just won't work. So it's good to just generally run this on an x86 machine if you're building images for a bunch of people, or bake in explicit support for ARM64. It works on Raspberry Pis and stuff as well, but again, when you're pulling down images, if they're not specifically built for ARM, you're going to have some issues. In the HPC world, we kind of use older kernels generally. So if you try to pull an Ubuntu 2204 or some latest greatest Fedora image into a Docker container, sometimes you can get weird issues with compatibility with the kernel. Like there's in Qt5 is a syscall that is only in newer versions, newer kernels, that's not in some of the enterprise Linux kernels. So it won't work, and it just gives you strange compatibility issues. So generally, if you're building a Docker container for use on HPC, use an older base image like a CentOS 7 or a CentOS 8 if you're running on anything that's RHEL 8 based or RHEL 7 based. And Docker is essentially root. So on a shared system like HPC, it can get a little bit weird. So we don't generally encourage running Docker in HPC environments. There is rootless support, but it's not great. It's kind of in its infancy, and there's a lot of gotchas when you're running Docker in a rootless way. networking is really hard and pretty slow in rootless, and a lot of the ways it determines what the user is not intuitive at all. So I wouldn't recommend using Docker in HPC, but there's an answer to that. Apptainer / Singularity. So Singularity is the old name. It was recently open sourced completely, and there's a whole new governance and everything, and it's under the name Apptainer now. So what is Apptainer? Formerly known as Singularity, is a container engine focused on scientific computing in HPC environments. It alleviates a lot of the issues with using containers on shared HPC systems because you don't have to use root. It has no long-running daemon process, and the containers run as the user that executes them. It's much easier to use this in HPC, for both from an administrative perspective and from a user perspective. So installing it, you don't necessarily need to install it on a local machine if you're using it on HPC, but if you want to build custom images and move stuff around that way, or if you want to test stuff, it's useful to have installed. So it does not support ARM. So I'm running all this in an external x86 virtual machine. And with Windows, you need to install it in a Linux VM. Though I've had some good luck with WSL2. It's not supported, but it does work for the most part. So here's how I got it onto Fedora. The Fedora edition I was running didn't have the kernel module for SquashFS loaded in by default, so I had to install that first. But yeah, just you run this command from the command line, and it installs that latest Apptainer release from GitHub. So let's do the same thing as before, run the Docker hello world. I guess one thing to note is Apptainer supports the syntax of Docker : // and that lets you just pull down Docker images and convert them into Singularity or Apptainer images. It's pretty nice. So after running that, I get the same thing. Hello from Docker. It's a lie. It's Apptainer. But it's the hello world image from Docker running in Apptainer in a rootless mode with pretty much no fuss. So you can also build redistributable containers with Apptainer. So with Docker, it's a little difficult to build like just raw files to just distribute. Generally, the way you work with Docker is you build an image, you push it up to Docker Hub, and then other people pull it. With Apptainer, you can just build a file. So let's just build that. It already exists, so that's good. I already built it. And then you can just run it directly. Just kind of neat. They build a small version of the Apptainer runtime into the image, so you can run it directly as an executable. That's kind of a show-off thing. I wouldn't generally do that in the real world. This is generally the way that I would run it. So Apptainer run, and then the image file. So yeah, hello from Docker again. This image gets run a lot. So let's build some custom images. So let's look at some methods. Two common methods. So there's a Docker method. You can compose a Docker file, build an image from the Docker file, push it to a Docker Hub, and then pull it with Apptainer and run it directly, or build a CIF, just like we did up here. So built a CIF, or we just ran it directly. Or we could do the Apptainer native image definition file. And they both have pluses and minuses. Generally, the Docker method is a bit easier if it works the first time. If it doesn't work the first time, then you're in for some troubleshooting. The Apptainer one is more like just building a system from small parts. Like you would start with an Ubuntu container and then apt-get whatever you wanted, and then set up what you wanted to be executed. So let's go through the Docker method, and we'll just do the same same custom image that I did before, that little index.html. So same thing, index.html, hello world, fancy custom container, hooray. And here's one of those gotchas. When I was playing with this, it didn't just work. So I needed to put in a custom Nginx configuration. Number one, because I couldn't listen on port 80 because that's a privileged port. So I needed to switch it to 3000. And number two, the configuration that Nginx posts on the Docker Hub is very, very Docker specific. So there were certain bits and pieces that didn't work very well. So we override it with this, basically the most simple Nginx config you can possibly have. So same as before, from Nginx, copy src, user share Nginx HTML. So that copies over our custom code. And then I'm also copying over this Nginx configuration file, nginx.conf. And I'm putting a very wide permission on this Nginx cache so that basically any user can run or can write to those directories inside the container. Now, this is not as scary as it looks because you, as a Singularity user or Apptainer user, are never outside of your user context. So anything that's run in there it's just you. It can't be anybody else. It can't be root. The permissions are not elevated. So let's send that over to the VM. And now let's build it. And to show that this is actually working, just delete this. So we built this Nginx extended app. So I've prefaced it with my fake Docker Hub. I mean, it's a real Docker Hub name, but there's nothing really there. You tag it with your Docker username and slash, and then the name of the container, and then colon, and then the version. So it's good to set a version so you're not always running from latest. There are problems with using the latest tag on things, mostly that you don't really know what you're pulling down if you put latest up there. It could be anything. So running that build command, it sends all that just like before over to the Docker daemon, pulls down the image, drops our custom code in there, runs this group and chmod to change the permissions, builds, and then tags it as that. So that's on my machine locally right now. So in order to get it up to Docker Hub, you do Docker login, and then it'll ask you for your username and password, and you put those in there, and it'll drop your credentials into your home directory. Now it does do them unencrypted. It's kind of, you have to use some extra things to get it encrypted on a, but if you're on your local machine, it's not super critical. So let's just push that to Docker Hub live here. All right, so I pushed it. Sorry about the control characters. I'm not sure why those show up. I think it's not totally emulating a terminal. But yeah, so it's basically sent all those layers up, and now it's up on Docker Hub. So I can see that in Docker Hub. let's go over to Docker Hub and look at it. So cool. There's my Nginx extended app. I have version 1 and latest. And latest always points to the last one you pushed up. So now let's pull that down from Docker Hub into Apptainer. Right area. So somewhere. So Apptainer run, and then I'm adding this writable temporary file system. It's anything outside of your home directory and a few other temporary directories is mounted as read-only in Apptainer. But if you do this writable temp fs, it puts a little overlay on top of those so that you can write to it. But I'll go ahead and run that. It should pull down from Docker Hub and launch Nginx. It's kind of unceremonious in its launch, but it is up and running right now. So let's go back to Nginx here and see if we have our custom code. And we do. It's there. Let's turn that off. You can see here the log of me refreshing it like a madman. So cool. All right, so we've successfully used Docker to push an image up to Docker Hub and pulled it back down with Apptainer. And you can do that to extend pretty much any container you find on Docker Hub. So using that from syntax up here, let's get the Docker file real quick. Oh, I had it up here, didn't I? Yeah, okay. So using that from syntax, you can take any image from Docker Hub, grab it, put your files in it, do whatever you want to it, move stuff around. You could, let's say, like you wanted to put a new version of TensorFlow in a Jupyter notebook container. You just go in and you probably have to figure out where the virtual environment is for the Jupyter notebook container, where it's running, that kind of stuff. But in essence, you could just run some commands in there, grab new versions of whatever you want, and then push your own image up to Docker Hub and then pull it down on an HPC system through Apptainer and run it with not a lot of fuss. That's a pretty good workflow, I think. The other way you could do it, this requires you have Apptainer installed locally. You could do an application definition, or Apptainer definition file. And then notice this looks pretty similar. Like I'm bootstrapping from Docker, and then it's grabbing the Nginx container, and then it's building with these files. I don't have any environment variables set up or anything, but that's just in there to show you that there's a bunch of different sections you can put in there. And then in the post, I'm running a few commands, and I'm not changing how the container is executed or anything. So just this small image definition file can build this CIF file. So I'll change the name real quick just to make sure that it runs. Context is off on that one. Let's just do it in the terminal. So I have this image def. Same thing as you saw in the presentation. Do that image stuff. And so let's do Apptainer build. It's going to build that SIF image from that definition file. That. Oops. Build that again. This takes a little while. One, because my virtual machine is a little slow, and two, because I think this Nginx image is based on Ubuntu. I could pare it down by using something like Alpine, makes it look much smaller image, but let me do that. Yeah, so actually it's not too bad. It's 52 megs. So Apptainer from the writable temp file system again. And if I could spell it correctly, that would have just started right out. Okay, so that should do the same thing. Give me my awesome fancy custom container. So which method you use is up to you. Doesn't really matter. They both end up in about the same spot. I find that the image definition file, you're going to run into less weird issues with Docker stuff. So if you're building your own container from scratch, I mean, even if you're doing like, if you build it from like a Debian rootfs or an Ubuntu rootfs, you get even more control. But you lose all that extra Docker stuff that's going on in the background. It basically, whatever's in this image def file is what's running. You don't see any extra stuff. I find it to be a little more, you get a little more control. It's a little more minimal. I think it's easier to control. I like doing the image def file a little bit better. But Docker way is way quicker. And it's nice to just drop your container on Docker Hub and be able to pull it down anywhere. With the image def way and building the CIF, you got to move that CIF around wherever you want to run it, because it's not just going to run it from Docker Hub. You have to carry that CIF file around, and they can get pretty big. So if you're pulling in CUDA, TensorFlow, and PyTorch and a bunch of other stuff, and if you have any models in there, I mean, your images can get in the gigabyte range pretty quick. Now on that stuff, I recommend if you have really large files, don't put them in your CIF, mount them in. So you can do bind mounts, just like in Docker where you can do volume mounts, you can do bind mounts in Apptainer. So if you have access to a folder, you can bind mount it into the container and then use the files from outside inside. I find that's a better way to ship large files around. That way you're not carrying this giant duplicated CIF file around. So yeah, that's building Docker and Apptainer. images in a nutshell. I could show a little bit of our open on demand and how we use Apptainer images on our system. So we have this interface called Open On Demand. It's a web interface to our HPC. We have these interactive apps, and a few of them use an Apptainer container. A notable one is the desktop app. So we'll go to the desktop app. We don't need to use many resources here, so just going to go with the defaults. And what this does is it goes and runs a script in the background, starts a Slurm job that contains the Apptainer container image for a self-contained desktop. And once it starts, I can jump in there. And I have a remote desktop that I can use. I think it even has Firefox baked in. So this is all running inside of a container. So I can get a terminal. Well, SSH. Oops. Let's see. What am I running on? I'm on Infer 17. All right. SSH localhost. Better demo if I have my keys set up right. But in general, you can SSH to the local compute node and run anything from the local compute node that needs a X session inside of this desktop. Not sure why that's not working at the moment. It was working earlier. But stuff like MATLAB or ParaView or any of that stuff, you could SSH localhost with X forwarding turn on and then run that inside the desktop container. Now, since that wasn't working, I'll just go back to the dashboard here and I'll just run it directly. It's doing the same thing. Let's do the MATLAB one. So there, now I've got MATLAB. Scaled right. There we go. Cool. So basically an entire desktop running on on the HPC system and being forwarded through your browser. It's pretty performant. It's not going to wow you with 60 frames 3D graphics or anything, but it's good enough to run some code and play around. It works with peer review, but again, it's not super fast. But yeah, that's all using Apptainer in the background. So yeah. All right, so that's about all I had as far as presentation. Have any questions? And feel free to unmute and ask a question directly if you have it. Or I'm watching the chat as well.
Hi. I know that Docker is used a lot in cloud systems. Is Singularity used in HPC systems like relatively the same way as Docker is used?
Yeah, pretty much. It's a little different than Docker in that it's all rootless and you're really contained to just the one user. But other than that, they're pretty equivalent. You don't get stuff like Docker Compose or Docker Swarm or any of that stuff. But as far as just running an executable in a container, it serves basically the same purpose.
But are people adopting it? Like, do they prefer using Singularity in HPC systems?
Yes, Singularity or Apptainer is really highly preferred in HPC environments, especially the traditional batch style ones where everyone's kind of sharing the same user space. So if you're running like Kubernetes or something, you probably don't need to ever look at Apptainer. Or if you're running your own cloud VMs and things, Apptainer is probably not something you need, but it's really focused on that traditional HPC shared system style. And it mostly focused on solving the issues of running containers in that environment.
Thank you.
Yeah, no problem. I believe Apptainer is already on Tinkercliffs, but you can just use Singularity. The command is aliased. They're basically the same project. It's just a name change. think they're introducing some new features in Apptainer with the ability to build images without having to be root. Yeah, okay. So yeah, it's not in the module system yet. But yeah, I mean, just substitute Singularity for that and it's the same thing. I'm glad to hear it's working for you. I think most of the apps in Open On Demand are using Singularity in some fashion. It's a nice way to carry your environment with you. All right, if there are no more questions, I'll just end it here. Thanks for listening to me ramble for 45 minutes about Docker and Singularity. I hope y'all got something out of it. So thank you. Appreciate you showing up.
Thank you, Ben, for the amazing presentation. Are there any more questions? If not, we can then conclude the session.
All right, thanks everybody.
तिमीले मेरो कम्प्युटरबाट नि लगइन गरेको छैन भने अनि मेरो कम्प्युटर दुईटा कम्प्युटरबाट ट्राई गरेँ हैन मैले
Okay, so I'll begin. Hi everyone, I'm Mayank. I am a CS grad student here at Virginia Tech, and I'm currently a GRA on the Open On Demand project, which is managed by the Advanced Research Computing team here at Virginia Tech. Today in the presentation, I'm expecting this to be a very short one. Today in this presentation, I'll demonstrate a bit about the capabilities of Open On Demand and how it enables building custom passenger applications. We'll also see what actually is passenger and follow the next steps there from there. So like before I start, I'll begin with a short introduction of Open On Demand. You would have probably seen a little bit of introduction about Open On Demand in the previous sessions. So So open on demand, what it does is it enables us to access remote compute resources with ease over a web UI. So what that means is, for example, you have a CPU or a GPU available in a cloud data center, available in a data center that is like in a different location. What is the usual way to access it? It's SSH, right? So if, let's say, there's someone from not necessarily a software or computer science background, they might not understand what SSH is, but they should have access to compute resources. And this is the problem that open on demand like tries to solve for. So those people can, with open on demand, the people who want to like access compute resources but don't understand the technical nuances, they can get started in like minutes, just because it is available easily over a web user interface. So this enables them to perform their job and like be productive on their actual job rather than figuring out the technical issues or any technical nuances. So this is a dev-oriented setup. Like what we'll be doing in this tutorial is we will be setting up open on demand in our local. Um, if anyone wants to follow through, I can paste the commands in chat. Like we will just, it's basically a 3-command setup, but it takes around like 10 to 15 minutes because it needs, um, I'm sorry, yeah, it needs to pull around 10 gigabytes of, pull and extract around 10 gigabytes of data. So it takes like around 10 to 15 minutes to set up, to get started with. So what we will, the main prerequisite here is Docker. As we probably know that Docker is something that is used to create and share containers. And with that, we can easily set up like web-based applications. Uh, so I don't want to go much into what Docker is. But yeah, that is one of the prerequisites for setting up, if you are interested in setting this up. Uh, so what I'll do is like, go ahead and just paste the, I'm sorry. Wait a second. So what I'll do is, yeah, go ahead and paste the Git link and the commands that you need to run in the chat if you are interested. I'll also probably make sure that you receive the slides over email later if you want, if you're interested in the slides. I need 1 minute for that. I'm not able to access the chat. I'm sorry, I'm sorry about the difficulty. Yeah. I'm sorry, please ignore the previous command. This is the command that you need to run. And so HPCTS is a small command line utility that is like written to like manage all the container services created by Docker for open on demand. Yeah, I'll get back to my presentation in a bit. And yeah, I have also shared the username and password. So this is a default admin user that is created for open on demand. It is pre-created for you so that you can access it in your local. Now, so if yeah, okay, so I already have the git clone command already run, and I'm already in the directory for that toolset. So I'll go ahead and just start my server. So if you can see, this was pretty fast for me because the images are already pulled for me in my local. So I don't have to make the effort of like going in and running that. But yeah, I can now go ahead and access Open on Demand directly on my computer. So I'm sorry. And if everything is running fine, this is the portal you'll be able to access. As you can see, it is running on my local host. We'll come back to it in a bit. And yeah, so there are two types of on-demand applications that are basically that it allows us to develop. So one is called interactive app and the other one is called passenger app. Interactive apps are essentially the plugins that are needed. Essentially are the plugins that act as plugins. They have a predefined template. And since they have a predefined template, we just need to like follow their template and build a plugin. For example, there's a Jupyter application on Open on Demand, which is an interactive app. I can show how it looks like. So um, this is like the Open on Demand local setup running on my own computer. So if I go ahead and start a session for Jupyter, I can directly access it. So what it means is if you have a remote cluster available, if you have remote compute resources available, you can deploy Open on Demand to that cluster and it will start managing it. And since it will start managing it, you can access various applications running on that compute cluster over the web. So this is a Jupyter notebook, which is running on my like system, but available over web. So it is pretty similar to Colab if you have used Colab. So I can create, let's say, a new notebook, and this will import. Since torch will not be available, so it will just say torch is not available. So yeah, this is a full-blown Jupyter notebook running in web browser for us. So this is one of the types of application that Open on Demand supports. The next type of application is passenger applications. So a passenger app is so what is passenger? Passenger is like an application server, and passenger apps are full-blown web applications that we can build and run directly using Open on Demand. So this enables us to like build more custom use cases and so this basically enables us to support more custom use cases. So if we don't wish to run a plugin, we can like build our own web application, and those are called passenger applications. And this directly allows us to like build RAG-based Ruby applications, WSGI-based Python applications, or Node.js applications. So I'll be demonstrating a small tutorial on how we can get started with the passenger application using Ruby. And as it is written in the presentation, it's actually incredibly simple. We'll just be building a hello world Ruby application, and that we'll also be using the Sinatra web application framework. Sinatra is a web framework to build Ruby web applications. So it's like Ruby on Rails. It's like Flask or Django in Python. Sinatra is a web application framework. So what I'll do now is like navigate to Open on Demand. If anyone was following through, like it's pretty easy to get started. Like you just have to run the command hpcts start, and then this all the entire state will be like this will all should get into the done state. And once it is running, you will have the access to Open on Demand in your local. So yeah, I'll go to my sandbox applications. As of now, this is a fresh install of Open on Demand in this system, so I don't have any sandbox applications available. What I'll do is go to launch files. So as I said, like about passenger enables us to build custom use cases around Open on Demand. So this itself, the files application, this itself is a passenger application running on Open on Demand. So this is one of the use case that enables us to extend the functionalities of Open on Demand directly. So yeah, what I'll do is go ahead and create a small new directory called, let's say, test app. I'll go inside this test app. I'll create a new file. So for Sinatra, we need this is the entry point file that we need to create. So what I'll do is just go ahead and create a new file called config.ru. I'll edit it. And this again, this is the editor is also running in browser. So this is also another extension of like, this is also an extension to Open on Demand built as a passenger application. We can even replace this editor by, let's say, VS Code. So VS Code now has, VS Code also has a web port available. So what we can do is like, instead of this editor, we can have full-blown IDE running in our browser, and that will be managing a compute cluster located far away in a remote location. And we don't have to understand or bother about setting anything up in our locals. So yeah, I'll go to like this. I have very small Hello World application code already written out. So I'll go ahead and copy paste it here. I'll save the file, and that's it. Like this is the root route that I need to create. And what my application will do is display Hello World. So I'll go back to my sandbox applications. Now I can see that there's a test tab running. It is complaining about a manifest being missing here, but like that is not a required component. It is just like providing more information to Open on Demand. We can set an icon in the manifest. We can set up a name for the application. We can set a description for the application. So this manifest is all those details. So I'll go and go ahead and launch the test application. It will say this is the first time that this application has been launched in Open on Demand. So it is asking me to initialize it. Once I initialize it, I can see that what change I made there, it is available now as a Hello World application. Now let's say if I wanted to make a change to this application, anything like I just want to remove this Hello World and just change it to Hello. So yeah, I will just need to restart my web server after making this change. I'll go back and launch, and I can see that the change is available on the change is available on the application now. And that's pretty much about like my tutorial, and this is how easy it is to create. So how easy it is to create a new web application using Open on Demand, and we did not even hit our IDE at all. We did not need any local setup for building this, and we did not need to do once Open on Demand is up and running in our compute clusters, we don't have to bother about setting anything up on our own like desktops or on our own computers, and we can do our entire workflow online without like doing anything, without making any effort at all. So yeah, that's pretty much about my presentation, and if there are any questions, I'll be happy to answer them.
Excuse me, is the on-demand username and password ID or virginiatech username and password ID?
So it depends. So if for now, so what I displayed here, this was the Open on Demand that I'm running in my local. So this is local to my computer. This will be local to my database. But let's say if I go back to the installation of Open on Demand, which is running for virginiatech, which is od.arc.vt.edu, I will only be able to access it using my VT credentials. 1 second, I think I need to turn on my VPN.
Yeah, I did get asked for username and password for this localhost page.
So yeah, so that is not your virginiatech ID or password. I shared username and password in chat. So that will be the local data. 1 second, I can share it again. Or let me go back to the slides.
I see it. Thank you.
Yeah. So
he's running that on his local computer. So he's not running that
right.
on the ARC. So I have a question. So PR works with me. So I can just ask question. So can you, so this one is to run this on your local computer, but if we want to do something to like external people to access ARC, can we use this on demand to build a web server?
Yes. So the thing is, I demonstrated this in local because we do not have. So this is from a developer standpoint. So let's say if I'm working on building more applications for Open on Demand, if I want to set up everything in my local to build more functionalities to Open on Demand, then I will go ahead and then I will use the local setup. If not, we can use the setup available for. So I have some issues with my VPN, so I'm not like go to this link.
Yeah.
This is the hosted link for VT Open on Demand.
Yeah, we use this all the time. So my question is, to use this, so we have all these pre-installed apps on demand,
right?
But then if we make one for
external
group,
users,
for external users, so
so they need to be in our because they need to be in our VPN. So this is more for like security reasons of our own network.
Okay.
So if someone wants to, so the goal with Open on Demand is providing compute easily over network, over web, right? So if someone has compute clusters available, and if they want to like make better use of it, they can install Open on Demand on their compute clusters and then access it just like we do here at ARC. So this is specific to like our university. This could have been open, but like university, because of university policies, we have it as an internal setup.
Okay, so let's say it's internal setup, but then if me myself or maybe PR is going to make an on-demand app for a Shiny R, you know Shiny R, right? So if we do a Shiny R app only for ourselves, where will be the home directory? For example, if PR make one in his on-demand account on Tinkercliff, so is that sort of hosted on his own directory, or and then in terms of using resources, are we using the head nodes, or are we using one of the
if we want to create application for on demand and share it with others inside of virginiatech, we will probably need to like go to ARC, like we'll need to ask ARC about it, and it will probably come back to me, and I'll be building that application for you. If you have it pre-created, what we can do is like so since this tab, if you see, this is not available for everyone. This is only available to the admins and the developers for the platform.
Okay.
Right. So I have additional options available which I can use to like create an on-demand app, test it, and then make it available to everyone in the virginiatech network. Right. So so let's say if you want to create something, you can probably, what you can do is like create a support ticket to ARC and then explain what is the app that you're looking for. And then maybe we can add it to our backlog, and then like we can make it available to you and the others who want to use it.
Okay, I see. So what if we want to I'll figure out, we want to put something like this, but then how long it takes? Let me see, I can send you this link. We are interested in install this one on one of the servers, so we can use that for some single cell data analysis. But I'm not, it's a Shiny R app. So I basically open the tickets and ask someone, and then they will come to you to make this happen.
They'll come to my advisor, who is Robert Settlage. Then if the team thinks that this is something that is being requested like multiple times, or if this will add value, or let's say if this will add value to your research, then we can pick it up. Then we can add it to like, then we can add it as an application, just like Jupyter is available for you to use. This can be.
Okay, I see. Let me think. So open up it to outsiders will be harder, I guess.
Yes, because this is only available inside of virginiatech, because you would be using Pulse Secure, right? You would be using Pulse Secure to access, or you would be using the EduRoam network to access it.
Right.
So this is an internal.
Actually, if you open up to the old EduRoam people, that would be actually okay.
This is open to all EduRoam. Yeah, this is open to entire EduRoam.
But you have to have a Jet ID to be able to get in, right?
Right. Yeah. To be able to log in, you have to have the virginiatech ID.
Okay, I can talk with Bob and see what he says. So this is what we want to implement. This is called Azimuth our Shiny app. And we want to do the single cell for plants.
Sounds good. So
can you do this also on AWS, for example, if we don't go through ARC?
So yeah, I mean, it is. So what if you have, let's say, a compute node available on AWS? What you can do is create your own installation of Open on Demand on that node, and then use.
I see. Yeah.
The way I just showed, that this was a tutorial setup. There's more in detail setup about Open on Demand. This was intended to be like running for our personal computers just to test out how Open on Demand works. So there are more documentation about like how to set up Open on Demand on a compute cluster, and then you can have your own running version of Open on Demand for yourself on your compute.
Okay. Okay. I think I will talk to your advisor and see
Right.
how he thinks. Very good. Thank you so much.
Thank you. Okay, if there are no more questions, I'll be dropping off. I'll leave my email here in the chat so that if you have any follow-up questions, you can probably email me.
Thanks for the presentation.
Oh, thank you. So I've left my email in the chat. If there are any questions, just like direct them to me directly. Thank you.